Okay student, in the previous video we have started with the new chapter, that is differential equation, that is 6th chapter from the part 2. In that, in the first video we have seen that how to find the order and degree of the differential equation, as well as we have seen what is the differential equation also. We have taken few examples also of how to find the order and degree of the differential equation. Okay, we have finished with the point 1 or exercise 6.1 in the previous video. Now we have to see the second concept or next concept from this chapter is the formation of differential equation. Formation of differential equation means how to find or how to form or how to generate the differential equation that we are going to see in this point. Okay, so I have written one example here. If you see that, form the differential equation of family of circles touching the y-axis at the origin and having their centers on the x-axis. Okay, here we have to find or we have to generate or we have to form a differential equation of family of circle. But that circle is touching to what axis? It touching to y-axis, but the centers are on x-axis. So we have to draw one diagram where their centers are lying on the x-axis and that circle is touches to the y-axis, and then we have to form the differential equation. This is our basically the question. So let's draw the diagram first. Okay, this is your x-axis and this is y-axis. What they say, the equation of family of circle are touching to y-axis. Okay, so I will draw one diagram on one circle which is touching to x-axis. This is the circle, and they say the centers are on x-axis. So this is the center. Okay, suppose this center now. See, for this center we are not using y coordinates, provided your y coordinate is 0. And we know center is always denoted by h comma k, right? So I write that h here, k is 0 because y axis does not exist, so y coordinate is 0. Okay, so this is our required circle, and we have to find the equation of this circle which touching to y axis, but their centers are on x axis. So center I have considered here h comma 0. So what is the equation of circle when the center is h comma k? Okay, so equation of circle is x minus h bracket square plus y minus k bracket square equal to r square. Correct? But what is the r? R is radius. It means from this origin point to this center, what is the distance from this to this? It is h only because O to C distance is h, right? And what is the k? K is 0. So how do you write this? X minus h bracket square plus y minus 0 is just y square and r square is nothing but h square. Okay. Now here that h is and this h and this h is your arbitrary constant. So when you are forming or when you are generating any differential equation, you have to get rid of or you have to delete that arbitrary constant or you have to eliminate that arbitrary constant. Okay, so this is the fundamental thing in this point we have to see. We have to eliminate arbitrary constant. So if you expand this bracket, what you will get? X square minus 2 times xh plus h square plus y square equal to h square. Right? So you can cancel x square from both sides. So what you get? X square minus 2xh plus y square equal to 0. Now we have to form a differential equation from this equation of circle. Okay? You have to eliminate this 2h. So how to eliminate that we will see. Now this x square and this y square I will write here, and on the right side I will this minus 2 is become plus 2xh. Right? Now take derivative on both sides. Here we will do that one. Okay? X square plus y square 2xh. I write that there is no simplified form. 2h is constant and this x square plus y square is on the left side. See, h is constant, 2 is also constant. But h is known as arbitrary constant. Okay, 2 is just constant, but this h is arbitrary constant. So now take derivative on both sides because we want differential equation of family of circles. So x square derivative is 2x plus derivative is 2y, but derivative of y with respect to x is dy by dx is equal to, on the right side 2h constant, so write that 2h as it is, right? And extra derivative is 1, so 2h into 1 is just 2h. So what you have, 2x plus 2y into dy by dx equal to h. Okay? So this 2x plus 2y dy by dx, this is the value of 2h. That is the value of 2h. So can I replace that 2h here? Can I replace that? So what will be here? X square plus y square as it is. 2h is to replace by this total term, and this x will multiply here. This is one way. And another way is you can differentiate this function. If you want to directly differentiate, this 2 and 2 will get cancelled. So what you will have, x plus y dy by dx equal to h. This is not a complete differential equation form, because h, that arbitrary constant is still there, so that also we have to eliminate. So how we can eliminate? By taking derivative again. So x square derivative is 1 plus, but y into dy by dx when you are taking derivative, don't forget y and dy by dx are two different functions, they are in product form, right? So when you are taking when we are taking derivative of any two functions when they are in product form, we use product rule of derivative. So what does the product rule say? Keep first function constant, take derivative of second, plus second function constant, take derivative of first function. Okay? So I will take derivative of first function constant is dy by dx का derivative d square y by dx square, plus now second function constant is dy by dx, and take y का derivative, that is again dy by dx. H is constant, x का derivative 0 because this is constant, right? Now 1 constant, this y into d square y by dx square, plus dy by dx into dy by dx, dy by dx whole bracket square is equal to 0. So this is your required differential equation of family of circle which is touching two axes and their centers are on x-axis. Okay, equation is 1 plus y into d square y by dx square plus dy by dx whole bracket square equal to 0. Okay. Okay, student. We have seen that how to find the differential equation of family of circle. Now we have to see, or we have to find out the differential equation, or we have to generate the differential equation by eliminating arbitrary constant, right? So next exercise is exercise 6.2, where we have to find this differential equation. So question is, find or obtain the differential equation by eliminating arbitrary constant. Okay, I'll write the question. Obtain differential equation by eliminating arbitrary constant. Okay, by eliminating arbitrary constants. Okay, so if you see here a is constant, then a and b are constant, then here again a and b are constant. That arbitrary constant we have to eliminate, and we have to generate a differential equation. So how to do that? Let's see one by one. So first equation is x cube plus y cube equal to 4ax. Okay. To generate the differential equation, we take derivative on both sides. So x cube का derivative is 3x square, y square, y cube का derivative 3y square, and only y का derivative is dy by dx. On the right side, 4a is constant, x का derivative is 1, that is negligible, right? So this is what 3x square, 3y square, dy by dx equal to 4a we got. But we don't want that a, so there are two ways. You can take derivative or you can 4a का value, this value you can put here, correct? So what you will get? Just a second. Okay, so 4a का value, this value I can put here. So left side I have x cube plus y cube equal to 4a is this term. So write 3x square plus 3y square into dy by dx, and this x as it is like this, correct? So this x distributed into bracket 3x square and this is become 3 3x cube plus 3x into y square into dy by dx, and your left side is x cube plus y cube. Okay? So what I will do, this x cube and y cube both I shift to the right side. So both will be minus and this become left side becomes 0. So 3x cube and this x cube become minus x cube, right? Y cube become minus y cube plus 3xy square dy by dx, like this we get, right? So 3x cube minus x cube become 2 times x cube minus y cube plus 3xy square dy by dx equal to 0. So this is your required differential equation. You can put that 0 on here also, on this side also, that doesn't matter here. Okay, 2x cube minus y cube plus 3xy square dy by dx equal to 0. This is your differential equation after eliminating that a arbitrary constant. Similarly here, ax square plus by square equal to 1. Here our a and b are arbitrary constant that we have to eliminate. So what I will do here, a will be constant and x square derivative is 2x. Then b is constant, y square derivative is 2y, and only y derivative is dy by dx is equal to what I get? 0. Correct? But still my a and b are there. Again I have to differentiate. But before that, these two and these two, can I delete this? So what I get? Ax plus b into y dy by dx equal to 0. But still that a and b are there. Again I have to derivative. I have to take derivative on both sides. So a is constant and x derivative 1, a into 1 is a plus b constant. Y into dy by dx ka when you are taking derivative, we have to use product rule there, because y and dy by dx are two different functions. Okay, so y constant है, dy by dx का derivative d square y by dx plus now dy by dx constant है and y का derivative is just dy by dx. Right side is 0. Correct? Now this a constant है, this b वाली term when I shift to the right side it will become minus b, like this, right? And this bracket carries y into d square y by dx square, and this dy by dx into dy by dx become dy by dx whole bracket square. Okay? Now what I will do, I will cross this equation number 1. This value of a, that is minus b times this whole bracket, can I replace that here? So at least a variable so we can delete, right? So this a I am replacing by this minus b y into d square y by dx square plus dy by dx whole bracket square. Okay, then plus b y into dy by dx equal to 0. Correct? Now see, this b and this b, they are common, right? If I factor out that b, so that b will get multiplied to both the term, and factoring out b, and then factor out b, if I shift to the right side, it will get divided to 0. So 0 by b is 0. So automatically b will also gone. So what I have is minus. Okay, minus sign also I have multiplied this bracket. So minus y into d square y by dx square. This minus will become minus dy by dx whole bracket square. This plus by into dy by dx equal to 0. So b we have factor also. So this is what differential equation you will get. Minus y, if you want, you can multiply throughout the equation by negative sign, so that first term you will get positive. So minus minus become plus, minus minus plus, plus minus become minus. This is your required differential equation. Y into d square y by dx square plus dy by dx whole bracket square minus y into dy by dx equal to 0. This is your required differential equation. Okay. Now let's see number 3. Y equal to a times cos of log x plus b times sin of log x. Okay. Just a second. Y equal to a cos of log x plus b sin of log x. Let's take derivative on both sides. Y derivative is dy by dx. A is constant. Cos derivative is minus sin. Okay, I'll write that minus directly here. Minus a sin of log x. Okay, cos derivative minus n, and log x का separate derivative 1 by x plus b constant. Sin का derivative is cos of log x log x का separate derivative 1 by x. Okay, here this x and this x is common denominator. When your denominator is common, we add the numerators, right? Then this common denominator, if I shift to the left side, it will get multiplied to dy by dx. Okay, so this x I am shifting to the left side like this, x into dy by dx, and add this numerator minus a times sin of log x plus b times cos of log, like this. Okay, but still my a and b are there, that I have to eliminate. Again, how I can eliminate that? Again, I take derivative on both sides. Let's see what I get. Again, but when you are taking derivative on left side when you have two functions x and dy by dx, right? So how you will take derivative of that term? By using product derivative. So what that product rule says, keep first function constant, derivative of second term, then derivative of second term. So derivative constant in second term, keep derivative of first term. So I'll write the first term constant, derivative of second term is d square y by dx plus dy by dx constant है, and x का derivative is 1, dy by dx into 1 is just dy by dx. No, minus a constant है. Sin का derivative is cos of log x, okay, and derivative of log x is just 1 by x. Then cos का derivative minus b times sin of log x, and log का derivative is 1 by x. So again you can see x and x is common denominator, so we can shift that to the left side. And when we shift the x to the left side, it will get multiplied to both the terms, right? So this x when shift to the left side, it will multiply to x. X into x is x square, and this d square y by dx square. This x shift to the multiply here will get x into dy by dx on the right side. Now see minus and minus common, take that common. You will get a cos of log x plus b sin of log, like this. Okay. So write this one as x square into d square y by dx square plus x into dy by dx is equal to minus. Now check this bracket carefully. A cos log x plus b sin of log. A cos log x plus b sin of log. That is nothing but your y. So I will replace this whole bracket by y, like this. So your final answer is x square into d square y by dx square plus x into dy by dx minus 1 become plus y on the left side. This is your required differential equation. Okay. Okay.